This is the 2004 AP Chemistry for response question from College Board, Form B. Question 5, Part A. What measurements must be made to determine the number of moles of sodium hydroxide used in the titration? The initial volume of standardized sodium hydroxide solution and the final volume of standardized sodium hydroxide solution are the two values we will need. Part B. Write a mathematical expression that can be used to determine the number of moles of NaOH used to reach the endpoint of the titration. We would do molarity of sodium hydroxide times the volume of sodium hydroxide. Part C. Number of moles of HA consumed in the titration can be determined by the 1:1 mole-to-mole ratio of HA to sodium hydroxide given in this reaction. We do moles of sodium hydroxide times 1 mole of HA over 1 mole of NaOH, which would have the moles of NaOH cancel and leave us with moles of HA. And the 1 mole over 1 mole is due to the mole-to-mole ratio in the reaction. And since we calculated the moles right above for HA, for part D, to determine the molar mass of the acid HA, all we need is the mass of HA. The mathematical expression that is used to determine the molar mass of HA is mass of HA over moles of HA. And here's the diagram for part F. This is the burette, and in the burette is standardized sodium hydroxide solution. And then we have the Erlenmeyer flask here, which has weak monoprotic acid, solid, and an indicator to detect endpoint of titration, as this will happen as the color changes when the endpoint is reached, when enough NaOH is added. G. Part G. Explain what effect each of the following would have on the calculated molar mass of HA. Number 1. The original solid acid HA was not completely dry at the beginning of the experiment. The measured mass of HA is larger due to the hydration of the acid with the water molecules still present on it. The mass of HA would be artificially large. This will result in the calculated molar mass being artificially high because the numerator has the mass of HA, which would be larger than normal, but the moles of HA would remain the same. Therefore, the overall molar mass of HA would increase, making it artificially large. And then number 2, the procedure called for 25 milliliters of H2O in the Erlenmeyer flask, but a student used 35 milliliters of H2O instead. This would have no effect on the calculated molar mass because, due to the mathematical expression showcased right here, the mass of HA over the moles of HA gives us molar mass, but since the volume of water is not present in this equation, therefore the molar mass of HA will not be affected, and the no effect will leave it neither artificially high or low, and then it will remain the same. The addition of water does not affect the calculated molar mass of HA. Again, this was the 2004 AP Chemistry for your response question, Form B, number 5.